Good morning and welcome to the June Tri-State Dairy Exchange webinar. Our theme for this year is Advancing Dairy Systems Through Technology, and this quarter we are focusing on precision agriculture technology and tools that support decision-making in the field and the barn. This month we're pleased to be joined by two folks from my team at the University of Vermont Extension Northwest Crops and Soils program. Jeff and Daniel are experts in the subject of precision ag tools and technology and are doing some really interesting work with our farm partners across northern and central Vermont. Up next in this webinar series in July and August, we will shift to our third quarter focus on automated milking systems, with presenters speaking to the technology and equipment available to folks to help automate and manage farm automation on dairy operations. If you know someone who might be interested in this series, please scan the QR code and share the registration link. And if you have missed any of this series, you can always get caught up by viewing the recordings on the UVM Extension Northwest Crops and Soils program YouTube channel. The goal of our Tri-State Dairy Extension team is to advance dairy management, address shared industry challenges, and foster innovation through collaborative educational programs across New England, specifically Maine, New Hampshire, and Vermont. All that to say that the folks on our teams have been involved in this industry for decades, and we really enjoy working with and for farms across our respective regions. We are Glenda at the University of Maine, Sarah at the University of New Hampshire, and Whitney, Kelsey, and myself at the University of Vermont Extension. We have a full summer of events and opportunities to connect planned for you. In Maine, new episodes of the Maine Farmcast are released every Wednesday. Recent episodes have focused on raising kids on the farm, practical advice on business planning and farm management for beginner farmers, and considerations for integrating both automated milking systems and manure collection systems into existing operations. Upcoming events that are part of the Technology Tuesday series include farm tours at Greenvale Farm and Witter Farm, featuring their automated manure and milking systems on June 30th, and a workshop facilitated in collaboration with Stonyfield and SmaxTech focused on herd health monitoring technology at Hardy Farm in Farmington, Maine. Both of these events are free, but registration is required. You can check out all of the UNH Extension events on their website. Of note are 3 event locations for mid-season field corn checkup and pest scouting in Claremont, Concord, and Stratford in July. And on July 23rd, Sarah will be facilitating an artificial insemination and reproduction workshop in Lancaster. And this looks like a really great hands-on opportunity. It's free, but it's limited to 15 participants, so you should probably register soon. And in Vermont, our UVM Extension grazing team, in collaboration with the Agency of Agriculture, is holding a livestock water system workshop in Randolph on June 30th, so next Tuesday. And they will cover water system design and implementation, tub and float valve setups, pump stations, and alternative water system options for production livestock. And starting tomorrow, our UVM Extension Dairy team kicks off the Future Ready Dairy Farm Tour series, where we will visit farms across the state that are improving efficiency, profitability, and resilience through technology, diversification, and herd and crop management strategies. Basically, these are informal farm tours and conversations to hear directly from producers about what's working on their farms, what they've learned, and what they're most excited about for the future of their businesses and the dairy industry. And this is a really great lineup of farms that are doing some really cool things. You can check out the details for each farm location on our website under the Conferences and Events tab. And we are just 1 month away from the 19th annual Northwest Crops and Soils Field Day at our research farm in Alburgh. This year's theme is Demonstration Derby, and it's going to be a full day of fun touring our research plots, autonomous weeding robot demonstrations, and afternoon breakout sessions, so you will not want to miss it. Lots happening, and we will drop all the links into the chat shortly. And in case you haven't heard, the DFA recently announced that they will be idling the St. Albans, Vermont processing facility later this summer. The Vermont Dairy Producers Alliance will be facilitating a roundtable discussion on the impacts of this on the Vermont dairy industry on July 2nd in North Hero. There's some additional information on their social media pages And you can RSVP to that discussion by emailing them directly through their communications email noted here. Our featured resource this month is the OneSoil app and platform. And this tool is a little bit outside of my work, so I hacked into Daniel's account to get this screenshot of the dashboard. This platform uses satellite imagery and artificial intelligence to support and keep record of agronomic practices for specific fields. One of the features it offers that's really cool is NDVI imagery, which is the Normalized Difference Vegetation Index. Daniel, you can correct me if I'm wrong, but it's calculated by using satellite or drone imagery to measure the contrast between visible red light and near infrared light that is reflected by plants. And you can look at different dates for a specific field using this platform. I think Daniel and Jeff might touch on this during their presentation, but our team is using this tool and the platform to look at the timing of green up for hay crop fields that have been renovated or newly seeded compared to those that haven't over the past few years. And I'm really excited to be learning more about this tool and how we can use it to better understand forage quality and management. And you can learn all about the different features of this platform on their website. All right, for today's webinar, we're joined by two folks from my team here in Northwestern Vermont. I really enjoy working with both Daniel and Jeff. They're both very knowledgeable about the precision ag technology that farms in our area and beyond are interested in, and they're working on some really exciting projects this year that they'll be sharing about today. As you might expect, this is a very busy time of year for them, so they were able to record their presentation on a rainy day last week, but we're lucky to have Daniel joining us from the field to answer any questions. So feel free to drop them in the chat as we go. And I will stop sharing. So Shannon, you can start that recording.
Good afternoon or good noon. This is a presentation on a precision ag in Vermont, given by myself, Jeff Sanders. I am a outreach specialist at UVM Extension, and I work a lot with equipment and farms. And my co-host is
I'm Daniel Bliss. I also work for the Northwest Crops and Soils program at UVM, and I'm the precision agriculture person over here, other than Jeff. So,
yep. So today we are actually pre-recording this presentation. Daniel will be in person on when this is being shown. I have an obligation which is going to keep me from being there, so we thought we would pre-record this presentation. So with no further ado, we are going to give you an update about what we have going on in Vermont with precision ag, and so we're going to run through this. So precision ag in our minds and how we apply it is the development and implementation of practices which improve efficiency, profitability, and environmental stewardship on farms. And so practically speaking, we're trying to use technology to hone in and apply kind of control variables better, so we can reduce waste and reduce inefficiency. So that's kind of the approach that we've taken, and we have a lot of stuff going on, and we're going to run through it quickly. So what we're trying to do is when we look at a field, we're trying to raise the level of production and the efficiency across all the different variables in the field, and trying to maximize efficiency and return on every spot in the field. So in some cases we're breaking the field down into smaller areas that get managed individually, and in other applications we are just treating the field with more precision, more precise measurements as we go. And the outcome of this ultimately is to also, from an environmental perspective, protect the water quality in the rivers and the lakes, which we know in Vermont is very important. So one of the things that we've done a lot of work on is optimizing planting rates and yields, and improving efficiency within the field, and obviously maintain profitability to the farm. So this is a picture of UVM's planter, and we this season we did about 1,300 acres on perhaps close to 20 different farms, doing no-till and conservation planting demonstrations and setting up different trials. And so we have an old planter, but it's got a lot of technology on it, which we'll talk about. And it actually performed quite well in 2026. So one of the things that we do is we use auto steer, and this has two main effects. One is it utilizes the field much better. You don't have any skips or swerves if it's working correctly, and then it also improves the efficiency within the field, because the rows theoretically are all the same, like they're straight, for instance. And also the added benefit of this is it keeps the driver of the tractor from getting fatigued, because they can focus on what the planter's doing instead of where the planter's going. Obviously you still have to watch, but you aren't so concerned with following a marker arm mark, especially in no-till, especially in sod into no-till, where you can't really tell where you've been. The auto steer corrects for all this and addresses that, so it makes it a lot less stressful planting, if you will. So we have that on our planter, and we've also helped farmers acquire these units from through a SEEP grants, and other people have acquired them other ways, and we offer some help in setting these up and using them. So one of the key functions of any precision ag planting system is the monitor. And here's the monitor that's in our planter tractor at UVM. And it monitors things like plant population, singulation, doubles, for seed spacing, and downforce, which is very important, especially in no-till systems, for you to monitor how well the gauge wheels are engaging the ground, so you can tell if the planter's riding up or down in the soil based on conditions. And you can adjust all these on the fly. Everything is controlled through the monitor, so you can precisely manage all those facets of planting. So for instance, if you're getting a lot of skips or doubles, in our planters, a vacuum planter, you can adjust the vacuum and or your speed to optimize, minimize skips and doubles. So this gives you more control over what you're doing in the field at any given time. So another thing that gets mapped when you're running a precision ag system in a corn planter or a grain drill, or any system that has down force applied to it, is it basically creates a map of the hardness of the surface of the field, because it'll automatically, and with our planter, which is hydraulic down pressure, it'll automatically adjust the downforce based on sensors that are in the row units. So essentially what you get at the end is a map of the surface compaction in the field. And like the field that we're showing in this slide, there's a lot of variability within the field. The darker areas are where more down pressure is applied. I think that downforce is measured on the gauge wheels. So if you will, the areas that are dark blue are softer, because the gauge wheels are hitting harder, and the areas that are light is where the gauge wheels aren't hitting as hard. And the field that we're showing, the light areas kind of on the top of the hill, if you will, is where there's a bunch of ledge and the planter just doesn't go into the ground as hard. So, and the around the outside, it was soft, is kind of a wet ear. And so the gauge wheels were pressing down harder. So you can kind of tell where the compaction is in the field and how hard the ground is by this. So in no-till systems, this is very important. You have to plant the seed at a consistent depth, and this helps you monitor that. So planters, there's a lot of equipment. There's a whole industry around seeders and planters. And one of the tools that we have implemented in the past is called a smart firmer, and it monitors several different things in the soil as you're going through. It measures soil temperature, soil moisture, organic matter, and conductivity in the soil. So you can kind of create a map of your field depending on how many sensors you have on your planter, to kind of monitor different aspects of the soil. And these can also be fed back into the system to adjust planting rates. And it gives like real time monitoring of the soil. So for instance, if the moisture readings were low, you could actually increase your planting depth to try to plant to moisture, to try to ensure that the seed would germinate uniformly in that field. You could do a variable rate planting scenario based on organic matter, where you could increase the planting rate where organic matter is high, because that generally would be more productive soil. So you can do things like that. And there's tools on the market that are available now today that facilitate this. Another piece of equipment which is very handy is like onboard scales. Here's a scale set up from Scale Tech this is on a seed down machine for seeding down or cover cropping, but it will tell you what's left in the bin or how much you've taken out of the bin and over a given area. And this is very useful for monitoring and optimizing seeding rates, particularly when you're seeding with dry granular product. There's a lot of variability introduced into the seeding process, which needs to be monitored. Even humidity changes in the air will change how fast the seed comes out of the bin. So having onboard scales, which you can monitor your rates on the fly, are very helpful to make sure that you're not over or under applying seed or cover crop. So it's a kind of a low cost. I think this scale system's around $5,000 or $6,000, and it gives you a lot better opportunity to monitor what's going on with the machine. And there's the scale circled. Another piece of equipment, which I have no experience with, but I could see where it'd be very useful, is a machine that measures what's going through each of the seed tubes. So like on a grain drill, it would tell you when tubes are blocked, and anybody who has much experience with grain drills know that tubes do get blocked. If you leave seed in them, the seed will germinate and grow, and it blocks the tubes. You can get mice in them. There's a host of reasons why seed tubes would become blocked, and this system helps monitor that, so you know when the seed's not coming out, so you can get a more uniform stand. We tend to try to only seed down once every so many years, so it's important that we get it right. And tools like this help us to do this. Another thing that we have been doing a lot of work on is variable rate fertilizer. So we are trying in these scenarios to optimize the fertility going on the field to the yield potential of that area of the field. So you can see in this slide that we have different fertilizer rates going on within the same field. And what we're trying to do is apply the nutrients in such a way that we won't lose any of them to the environment, which will improve water quality. And it just creates more efficiency in the system, which should increase profitability. And there's a few different ways that we do this. One of the ways we do this is by creating a productivity map. And there's two ways we primarily do this, and that's by averaging NDVI data, which basically is a measurement of crop vigor. And so we make the assumption where there isn't yield data that the more vigorous the crop is growing, the more yield that area of the field will produce. And then we might push fertility there, while in other areas of the field where there's poor productivity, we might cut fertilizer rates there, assuming that our yields will be lower. So there's no point to fertilize to a high yielding yield goal where it's not going to yield that. And that's generally a result of, in our area, internal water drainage issues or compaction. They just aren't going to produce. So we just cut the fertilizer rates in those areas. It's not to say that we're putting less fertilizer on overall. We're just reallocating the fertilizer to where the crop's going to grow the best. And this map kind of demonstrates the different areas of a field that our data collection and analysis would produce a zone map, if you will. So, and then for nitrogen, which is primarily what we're doing, we'll go get soil samples to establish the rates, a pre-site dress nitrogen test, PSNTs. And we do that generally for every zone in the field, and then assign nitrogen based on the results of those PSNT tests. So this is an image of a productivity map generated on the left and an as applied map on the right. So you can see how the zones were created and exist, and then you can see how the fertilizer was placed on the field. So that's kind of following that through. Here's the spreader that we use. Doesn't have to be this spreader, but what it does have to do is it has to have the ability to increase and decrease application rate based on inputs from the onboard computer. So generally, we call it a prescription. We load a prescription into the computer, and then the spreader has the ability to speed up or slow down the bed chain based on what is being called for, and it measures how much fertilizer it's putting out the back. So this spreader has the additional benefit of having onboard scales. Generally, you wouldn't need onboard scales. You can, once the computer knows how much fertilizer is coming out through the tailgate, but in any given time period, based on how open the rear gate is, it can do all the math. But this spreader has the added benefit of being able to compare that math with actual scale data, and it makes adjustments on the fly to make sure that the applied rate matches what the scale says is coming off the spreader. And it's very accurate to within a couple 100 pounds on 4 ton. So it works well, and it's kind of a neat piece of technology. As you can see here, we did variable rate on a bunch of different fields, And in general, we did see a slight reduction in the amount of fertilizer we used in most cases. And so what we have to do at the end of the season is measure the yields off of the field to see if applying variable rate fertilizer is profitable to the farm. So we aren't trying to reduce yields. We're trying to maximize yields. So the only check that we have on that is yield data off of the field. So, and we're still doing that. So right now, currently, we are setting up and installing these trials on a bunch of fields again in the summer of 2026 to see once again if this is working to maximize yields. So at this point, I'll turn it over to Daniel, and he's going to run through a bunch of other things that we're working on.
Okay, thanks, Jeff. As Jeff just said, I'm going to kind of continue the discussion on some precision ag technologies and some projects that we've been working on. So we'll begin with weed management. Weeds are obviously a pretty big deal for agriculture. They can reduce yields, compete with crops, etc. And the way that we manage them can be effective, but there are some holes in it and potentially some problems with water quality. So for precision ag, our main goals for weed management are to reduce herbicide use to some extent, improve water quality, and then just as important, if not more important, is we want to improve how well we can manage weeds, how efficiently, how effectively, and then ultimately grower profitability is a pretty big deal as well. So we'll begin with talking about aerial herbicide applications. These are primarily done with drones. It's hard to understate how important drones are to precision ag right now. They're kind of the hot topic on the block. They have so many potential applications. This is one of them. So in this particular example, you have a drone that's equipped with a spray tank and some nozzles. And you kind of just fly back and forth applying herbicide. The big benefit to this is that it keeps equipment out of fields, especially at times like right now when we just got 4 inches of rain in some places over the weekend. Trying to get equipment in there to manage the weeds could lead to compaction and just stuck equipment and all kinds of a mess. So the drone's really nice for this. It stays above the field, so you keep your equipment out of it. There are potentially a couple more steps you have to go through. Obviously, you have to have a licensed drone pilot who also needs to be a pesticide applicator. So there's potentially some more steps there. And then again, it also has limited capacity. You can see the tank on this is pretty small. I think in general, they say that the drone can't lift any more weight than it itself weighs. So if it's a 100-pound drone, you're going to be looking about 100 pounds of product on there. So that makes for fairly frequent fill-ups. So that's another problem. And then, of course, the weather has to be right to fly, although that's also true for applying with other equipment. So another form of weed management that's pretty big and is getting bigger over time with precision ag is what they call see and spray. You can see drones are important here as well. However, instead of actually doing the application most of the time, these are just actually mapping the field. So you can see that this drone here is equipped with a really high resolution camera. They fly over the field. This allows them to either feed this imagery into an AI program or create a map in another way. And basically, you can see this map on the right here. They've identified all of the weeds in this field, and these are extremely accurate. I think they can identify weeds that are as small as a 1/4 inch. So that's obviously highly accurate. And then you'd go in with your equipment. The map would be uploaded into your sprayer or whatever you're using. These would have section or nozzle control. So either a section of your boom or actually even individual nozzles can have on and off shut off. So as you go through the field, it sprays only where the actual weeds are. And as you might imagine, this this has the potential to really reduce herbicide use. You're not spraying one rate across the whole field. You're just spraying where it needs. So that's a pretty cool technology. There were a couple companies developing this. There still are. Centera and Blue River were some of them, but they were actually bought up by John Deere, so they're now part of the empire. But these technologies are becoming more and more common in agriculture. This one I called See and Destroy. It's a little bit dramatic, but you'll see why in a moment. How this works, this gigantic machine off the back of the tractor here has a really powerful AI program. Most of this machine that you're looking at is actually computer. So really powerful computer on there with a lot of cameras, which again are highly accurate, identifying really small weeds as it's going through the field. And basically what this particular machine does is as it passes through the field and it identifies these weeds, it actually shoots a laser at them. Pretty cool James Bond kind of stuff, but it's true. These things exist. Here's an example of how it actually looks when it goes through the field. So the picture all the way on the left is right when it shoots it. You can see it kind of scorches it right down to the roots, and then within a couple of days, it's completely dead. This technology, it's really expensive, and it's still being developed. This is something that you're not really going to see in row crops around here probably for a while. But it is in current use in specialty crops, so things that kind of demand a bit of a higher price, onions, peppers, etc. But it's definitely something to keep an eye out for because, you can see how this could potentially be sort of the future of weed management here because it's just so accurate. And it's mobile as well. So called that one See and Destroy. We'll move on to mechanical control. And here we have something pretty interesting because it's actually something we are working with this season. So the idea behind this is that you have an automated weeding robot that goes through the field. Obviously, you could take another machine, there are inter-row mowers, things like that. But that's not really what I'm talking about here. These things actually do it all on their own. And the picture you can see here is from Greenfield Robotics. These are what they call their botany lineup. And the idea is that these go through the field and they either mow down or potentially dig up the weeds. So they're not necessarily killing them. They're just managing them. But the nice thing is that they're fully automated. You set it up and supposedly they go out and they do it all themselves. And our program just bought 6 of these robots that you see here this spring. So we've been working with them. And I'll just talk a little bit about the project we're trying to do. So over here in Vermont, we have a bunch of fields located in Franklin and Grand Isle counties. And basically the idea here is that we want to see if these can actually work in Vermont and the Northeast. So where they were developed in Kansas, the fields are flat, they're really long with really straight rows, not many rocks, kind of ideal conditions if you were going to go out and mow some weeds. Vermont is kind of the opposite of that, right? There's a lot of different conditions. We have a ton of rocks here, hilly fields, all sorts of different conditions, oddly shaped fields as well. So our idea is to test these in as many conditions as we can get our hands on. I've listed a couple here, flat or hilly, organic, conventional, with a cover crop, no cover crop. The list can go on and on. So we've selected a bunch of fields that have these different characteristics, and we're going to perform some trials on them. I think starting Tuesday, which when you guys view this will be yesterday. So we'll see how it goes. A little bit of the setup required for these things. We're after having done it this year, we're coming to understand more what's actually required to set up these robots. So one of the big things was that we needed a base station for RTK level positioning data. And this thing has about a 15-mile radius. So we had to be really careful where we set it up so that all of our fields would be included in its radius. And then what we had to do is a representative from the company came over and he had a really fancy drone that actually broke. So he's got to refly one field. But basically we went out and we flew the fields to make a map. We sent it off to them. I believe they go through and create the actual map to see where the rows are. They wanted our planter data as well, just so that they could kind of compare the map to that, because they really don't want to hit any crop. And the reason for all of this incredible level of detail is because the robots are about 26 inches wide. And in a 30-inch crop row, which is what they're made for, they only have about 2 inches of clearance to the crop, right? So you can imagine that if it's off by a couple inches, you're going to be losing a bunch of crops. So that's why we needed the base station. That's why we needed the drone footage and the planter data. So now that that's all set up, supposedly they're going to upload these maps into the robots, and then they will drive themselves around the field mowing down the weeds. Supposedly they only stop for battery changes and other maintenance. And actually the robots will send you a text message on your phone when they need a battery. I believe they even bring themselves back to your location. So it's pretty impressive technology what they've done here. And then, of course, we're anticipating with all of our rocks that there's going to be some other maintenance involved as well. But these are some of the questions that we have, right? Nobody has really used these in the Northeast. So things we want to find out are how many acres can one of these actually do in a day? I think the company says about 7 or 8 per robot, but we don't know if that's true in Vermont. Can they actually control the weeds effectively? Obviously, they're mowing them down. They're not killing them. So are they actually an effective means of weed management? And then most importantly, are they cost effective? They can reduce all the herbicide in the world, all these great things. But if at the end of the day, they're making people lose money, they're not going to use them. So that's another important question we need to answer. So moving on from weed management, I just wanted to talk about some of the software that we use. This is obviously really important for precision ag as it's practiced today. So I just wanted to put up 3 of the biggest software packages that we currently use for all of our different operations. These are SMS by Ag Leader, John Deere Operations Center, and then OneSoil, which is a Swiss company. All these function in a very similar way. What they do is they'll take data from your equipment, data about your soil, basically all the data you could collect in the field, and they allow you to use it to make decisions. And I'll talk a little bit about that in a second, but I just wanted to give you a bit of an indication of the cost of these things, because that can be a point of curiosity. SMS is probably the most expensive. It's about $3,000 up front, and then about $800 in annual fees. I will say, though, that it is by far the most powerful of these 3. It's also the most complex to use. You basically need a degree in it to learn how to use it. But they do offer courses and stuff, but highly useful. John Deere Operations Center is supposedly free, although it only really works with their equipment. So however much their equipment costs is how much you're paying for John Deere Operations Center. And then OneSoil, this one is probably the least powerful, but it is by far the most user-friendly, which is really nice. And this is charged on a per acre basis yearly. So for instance, this past year, UVM bought access to 500 acres and it was a little under $900. So quite a bit less than the other 2. So what do these things do? What have we been using them for? So you saw earlier, Jeff showed you the productivity zone map that we use for the variable rate fertilizer. Those were created with these software. So the one that you saw was made through SMS. We have also made them through OneSoil. You can make planting maps, which we've done with John Deere Operations Center. All sorts of maps. They're really good at making maps. And you can see over here on the left that they can also actually do some measuring of their own based on satellite imagery. So on the top, we have NDVI. crop vigor, crop greenness, like Jeff said. The one underneath that is photosynthetic efficiency. They measure soil moisture, all these different things. So they have a lot of potential capabilities based on satellites. Obviously, one of the most important things they do is record your operations. This is important not only for making for decision making, but also recording things for state reporting purposes. That's really important. So planting, fertilizing, harvesting, they can record all those. One thing that we use a lot is their ability to produce charts and tables. I think they even do things like statistics, but basically whenever we report something and we want to talk about a project that we did, we can produce really useful charts and tables like the ones you see here, which can break down yields by zone, etc., etc., etc. They can also perform economic analysis, which is pretty neat. You can plug all your variables in and it'll tell you, are you profitable, basically, which is very useful. And ultimately, it's just helping us make decisions for future growing seasons. So now Jeff and I can probably both talk about this. Different challenges of precision ag. One of the biggest ones is equipment breaking or malfunctioning. Jeff has a lot of experience with this in particular.
Yes. So the issue that precision ag has from a technology point of view is that it uses electricity that goes through wires. And electricity and water and mud and dirt don't mix well. So and how you route the wires is super important. Here's a picture of a wiring harness that runs a row unit that got pinched because a zip tie broke and the wire dropped into the wrong place, got caught, and it caused some headaches. So it's super important to do all your preseason work and make sure that all those wires and hoses and are tucked away and firmly attached where they need to be and flexible where they need to be, because they do have to bend as well. So that's probably the number one thing that stops us when we're in the field is wiring issues associated with just the work of the whatever we're working with, having to go through the across the soil surface, and the bouncing and the jiggling and all that. Sometimes the technology can be difficult to set up and learn. There is definitely a learning curve with all of this, and so you have to be patient. It's not something that you want to throw on the day before you're going to go and think it's just going to go, because that's really not how this works. It's better to go a little bit slower, get things set up properly, and then be ready to understand that you're going to be on a learning curve with it. So that's for sure. And then also Daniel can talk about this one a little bit more.
Yeah, there's an issue with some data sharing because a lot of these companies have proprietary things going on, and so they aren't very good at sharing. Particularly, I will say John Deere. They are very, very poor at sharing with other companies. So, for instance, we often have to send different files between these, and there are a ton of different file formats, some of which you can only have with John Deere. Sometimes we have to reroute things through other programs to convert them into a file type to get them back to another program. So that can be a little bit tricky. And then another one, which we've actually kind of solved this year, is internet access. Vermont, and I'm sure other places in New England as well, have pretty poor internet access, but we got Starlink this year and it's been working fairly well so far. So seems to be that problem might be solved. And then there's always the issue of expense. A lot of this stuff is expensive. It's not always clear whether there'll be a return on investment. But it can make things easier. I think auto steer is the example everybody always uses. Like, you can't necessarily always point to a return on investment, but anybody who's used it will never not use it again because it's incredibly convenient and some things are actually more valuable than money. So yeah, I think that's everything.
Yep. So I'm not sure where we are for time with this, but Daniel will be available to answer questions um, after this presentation. We just thank you for attending, and we're looking forward to pushing this stuff forward. It is coming, it is here, and for the folks that can take advantage of it, we're here to help them do that.
Thanks very much.
Thank you.
Oh, thank you.
All right, that was super. If anyone has any questions, they can drop them right in the chat. We're gonna start it out here. Daniel, if a farmer in Vermont, a crop farmer or a dairy producer, is just kind of looking to dip their toes into the waters of precision ag tools and technology for their farms, where should they start?
That's a good question. I think it kind of depends on the size of their operation and everything, of course, because we've had people who've started with things just as simple as the auto steer, which is really helpful. But then other farms have jumped right in with getting Harvest Lab for their chopper or things like that. I think, yeah, the planting technologies that we mentioned, a lot of those can be a little bit finicky, especially those seed firmers. We've had those are kind of a struggle every year when we go out planting, so that probably wouldn't be the first place that I would start. But yeah, that auto steer is really hard to beat. It really does improve things. I think the fertilizer spreading as well. That one can be tricky because that spreader that we have is not exactly free. It's a fairly advanced spreader. And there we have had some complications setting it up as well. So I don't know if I would start with that either. Kind of a long-winded. It's kind of wherever they feel they have the most to improve, I would say. Um, yeah.
No, fair enough. I think that's great. Like, basically, you want to identify the farm, like specific farm goals, and match up the technology that fits for them, right?
Exactly. Yeah.
Right.
And there are some farms who already have some precision technologies that they've been using, but even for them, if they're starting out, they find out that there are additional technologies that would make it a lot better. Like I don't want to name any farm names, but I was at a farm this spring, which just got Harvest Lab, which measures their forage when they're harvesting it, and they called us down because they realized they didn't really know how to make the maps or anything, right? So sometimes even things like that, even if you're not just starting out, if you're already entrenched in it a little bit, there are some technologies that you can get that'll help that aren't a crazy amount of money. So
Yeah. And hey, like, I feel like one thing that we hear from farmers when they start adopting some of these technologies or platforms or tools is like how much data is like suddenly provided to them and how challenging it can be to, identify what information can be most helpful. So, like, what kind of advice do you have for these folks to like prevent the overwhelm from all the information that they're going to get with these, like, adopting these new tools, so they can really like figure it out and make it work for them?
yeah, that's man, you put your finger on it because that is so true. You start into precision ag, and all the data that you can collect is really, really overwhelming. I mean, all the satellite imagery, all the stuff your equipment's recording, different soil tests. The list just goes on and on and on. And it's all valuable. Like it's all stuff that you can use. I think that's definitely where the software that I was talking about really comes into play because that can help you kind of sift out what's really important, what's really going to make the biggest difference on your farm. And then it helps you use it as well. I know you had mentioned One Soil early on in the webinar, and that's one of those companies that does that really well. They for the price that they have, which is a pretty inexpensive price, they actually give you a fair amount. And it's pretty user friendly, which is nice. The SMS program that I spoke about, that one you almost need a master's degree in SMS to use. It's really, really complex. It's something that I'm currently learning to use. But yeah, I'd say starting with one of those lower level software packages and just watching some videos online to see exactly what it can get you. That's really helped us out over here. And I know a couple of farmers who have gone kind of that route as well, and it's really helped them as well. Uh, yeah, I mean, in terms of specific data that are more important than others, I mean, the ones that we probably use the most often are NDVI, and then the harvest data is also really important. But NDVI is pretty effective for planting and fertilizing maps. So I'd say that's probably one of those that we use more often. Yeah, so that's probably a good place to start. Again, depends on what equipment you have, what you're looking to do, what areas you need to improve. But
Hey, I think that's super helpful to know. There's a lot of similarities between the tech, like the herd health monitoring technology that folks are using in the barns and the technology and platforms that folks are using in their tractors, just in how we consume and actually use that information to make decisions, and so much to be learned. So it's an exciting time, right? I
yeah,
don't see I don't see questions in the chat, so you might be off the hook here, but I think the video that was looped into your presentation was maybe from yesterday. How did it go with the robots out in the field yesterday when you guys got them rolling? Or did
it's
you?
funny. I laughed out loud when I saw that play because that was gosh, Shannon can correct me here, but I think that was like 2 weeks ago, maybe
Oh,
even
okay. I thought
longer.
maybe it was yesterday.
Oh, yeah, yesterday was a bit of a bust. We had
Oh,
trouble getting the
bummer.
maps, so I'm actually, as we speak, watching these robots in the field. We just calibrated them, and for the first time ever in New England, as far as I can tell, robots are running autonomously through fields. So it's pretty cool. The video that you saw, that is the robot. It was going much slower than it does in reality. And that's because I was ineptly using the remote control walking behind it, as you saw. But
Okay,
yeah, those are the robots. They've got tracks on them, which weren't in the pictures that I showed. But yeah, they look like they're going pretty well. A couple dust clouds coming up when the blades hit a rock or something, but yeah. So
great. So we'll be looking for live demonstrations of those robots next Tuesday, the 30th, at the Henry
hmm
Farm in Alburg, and then also at our field day on the 23rd at Border View Farm. So you've got a couple days left to dial it in, huh?
Yeah, hopefully we're working on it. They are worth seeing. I will say that for anybody who's on the fence, they're definitely worth seeing. So the
Exciting
future is
time.
here, as they say.
All right. Thanks for your time, Daniel and
Of
Jeffrey.
course.
All right, up next in July, our webinar will focus on how automation is reshaping how dairy farmers manage daily operations, from milking to feeding and monitoring herd health. Presenter Chris Hill will explore how Laley's robotic systems are being implemented on farms across New England and the real world impacts on labor efficiency, animal welfare, and farm productivity. Topics will include robotic milking systems, automated barn management tools, and considerations for farms exploring automation for the first time. And you can scan this QR code to register for those upcoming webinars or visit our conferences and events page. And thank you for joining us today. If you could take a moment to complete this brief survey, we would greatly appreciate your feedback. And we hope you have a great day.